The story begins with one of the most shocking projects in modern car YouTube history, the rebuild of a damaged Bugatti Chiron after a serious crash. This is not just any car. The Chiron is one of the fastest and most expensive production cars in the world, powered by a massive W16 engine and built with extreme precision in a factory where everything is controlled down to the smallest detail. After the crash, many people believe the car was simply finished forever. In normal situations, a car like this would go straight back to the manufacturer or be written off completely, because even small repairs require special tools, software, and factory parts that are not easy to get. But in this case, the project was taken on by builder and YouTuber Mat Armstrong, who is known for rebuilding crash performance cars and bringing them back to life in his own workshop. From the start, the goal was simple but extremely difficult. Rebuild a Chiron without full factory support and prove that even a total loss supercar can be saved with skill, patience, and creativity. The challenge was not only physical but also mental, because many experts believe certain parts of the car could not be repaired outside of Bugatti's own facilities. Still, the team pushed forward. Every piece of the damaged vehicle was carefully inspected, and the scale of the job became clear very quickly. The car had been heavily damaged, and it was not just cosmetic issues. Structural parts, cooling systems, wiring, and key engine components all needed attention. Even at this early stage, the project already felt like something almost impossible. But instead of stopping, the team committed fully, knowing that every step forward would bring new problems that would need creative solutions. One of the biggest challenges in the rebuild came from the cooling system, especially the radiators. The Chiron uses a very advanced cooling setup because its engine produces an extreme amount of heat. During the rebuild, the team could not simply order replacement parts easily, so they had to fabricate custom components. A skilled fabricator named Bob built radiators from scratch using commercial cores and custom-made fittings. At first, everything seemed to be going the right direction, but problems started quickly. During a pressure test, one of the radiators developed a leak. This was not because the work was poor, but because a part had been damaged during shipping. The box had been dropped, and even a small impact was enough to damage the internal structure of the radiator. This caused a full restart of the process. Bob had cut off newly made sections, replaced damaged parts, and rebuilt the unit again from scratch. Just when things seemed stable, another issue appeared. A small measurement difference of only 1 millimeter between the new core and the old design created a major alignment problem. In a car like this, even tiny differences matter. Mounting points no longer matched, and brackets had to be adjusted and re-welded. After that, another issue appeared again. This time, small leaks formed due to tiny welding holes. The system had to be drained completely, which meant removing nearly all the coolant and starting over again. These repeated failures created frustration and delay, but they also showed how precise high-performance engineering must be. Even a tiny mistake could stop the entire project. Despite this, the team kept going, fixing one issue after another, slowly moving closer to a working cooling system that could handle the power of the engine. As the rebuild continued, another interesting discovery was made. Many parts inside the Bugatti Chiron were not fully unique to Bugatti. Instead, they were shared across the wider Volkswagen Group system. This included companies like Audi, Porsche, and Lamborghini. During the repair process, the team found that some components could be replaced with parts from other vehicles. For example, certain electrical modules and sensors matched parts from models like the Lamborghini Gallardo and Porsche systems. This showed that even a hypercar like the Chiron still uses a shared platform of engineering within the larger group. However, this did not make the rebuild easy. Many parts still needed custom work, and some were completely destroyed in the crash. This is where fabrication became extremely important. Bob, the fabricator, played a key role again by building complex parts from scratch when replacements were not available. One of the most impressive examples was the front crash structure. This part of the car is extremely important because it supports the front body panels, sensors, lights, and alignment of the entire front end. Normally, this would only be available directly from Bugatti, but since that was not an option, Bob carefully studied the damaged part and rebuilt it manually. He used aluminum materials similar to the original design and shaped them using cutting, welding, heating, and bending techniques. Every mounting point had to be exact, or nothing else in the front of the car would fit correctly. When the new part was finally installed, it aligned perfectly on the first attempt. This moment showed how skilled hands and experience can sometimes replace factory systems, even on extremely advanced machines like the Chiron. The front crash structure rebuild was one of the most complex parts of the entire project on the Bugatti Chiron. This component is not just a simple metal frame. It connects many important systems together, including the bumper, bonnet lock, sensors, headlights, and aerodynamic panels. If even one mounting point is slightly off, the entire front of the car becomes misaligned. Because of this, precision was extremely important. The original part had been badly destroyed in the crash, so there was no clean reference model to copy. Normally, such parts would be scanned using advanced 3D scanning equipment, but that was not possible in this case. Instead, the fabricator had to rely on the damaged part itself and rebuild it by eye and experience. This process took many hours of careful work, including measuring, adjusting angles, and constantly testing fitment. Each small adjustment had to be perfect before moving on to the next step. The material used had to match the strength and behavior of the original factory aluminum, or it would not survive the stress of high-speed driving. After many hours of shaping and welding, the final structure was ready. When it was installed, everything lined up correctly. Bolt holes matched, edges aligned, and panels could be fitted without force. This moment was extremely important because it proved that even highly complex factory-level structures can sometimes be recreated outside of a manufacturer environment. It also gave the team confidence to continue pushing forward with the rebuild. Without this success, the project could have easily stopped. Instead, it became one of the strongest examples of what skilled fabrication can achieve when combined with determination and patience. After many failures and rebuilds, the cooling system of the Bugatti Chiron finally reached a stable state. This was one of the most important milestones in the entire project because the Chiron's engine produces extreme heat and cannot run safely without perfect cooling. The team used a vacuum filling method to fill the system with coolant. This process removes air from the system and allows liquid to fill every part evenly without leaving air pockets. Around 39 liters of coolant were needed, which is a very large amount for any car. Once the system was filled, the engine was started for testing. At first, temperatures began to rise, which was expected. The team carefully watched the readings as the engine warmed up. Slowly, the system began to stabilize. The cooling fans activated, and the temperature stopped rising. This was a very important moment because it showed that the custom-built radiators and repaired system were actually working under real conditions. There were no leaks, no overheating, and no pressure failures. This meant the car was finally ready for the next stage, driving. For a project that had faced so many setbacks, this success felt like a major victory. It proved that even without factory parts, a carefully built system can still handle extreme performance demands. The engine was now stable enough to move under its own power, which meant the rebuild was no longer just a repair project. It was becoming a functional supercar again. The first drive of the Bugatti Chiron was one of the most emotional and intense moments of the entire rebuild. After all the repairs, welding, and testing, the car finally moved under its own power. At first, everything felt smooth. The engine responded properly, and the transmission engaged without issues. The car slowly began to roll, and for a moment, it almost felt normal. But the reality behind the drive made everything different. This was still a car that had been completely split apart and rebuilt by hand. Every sound, vibration, and movement felt more intense than usual because the driver knew exactly what had gone into fixing it. As the car gained speed, the feeling of power became overwhelming. The acceleration of the Chiron is already extreme in normal conditions. But in this case, it felt even more dramatic because of the emotional pressure behind the rebuild. The driver described feeling both excitement and fear at the same time. Even small acceleration caused a strong physical reaction due to the force of the engine. Despite the fear, the car continued to perform perfectly. There were no warning lights, no strange noises, and no mechanical failures. Everything that had been rebuilt was now being tested in real driving conditions, and it was holding up This moment proved that the entire project had reached its goal, a fully functional hypercar restored outside of factory conditions. In the end, the rebuild of the Bugatti Chiron became more than just a repair job. It turned into a demonstration of engineering skill, patience, and creativity. The project showed that even one of the most advanced cars in the world can be rebuilt if enough knowledge and determination is applied. Many parts that were expected to require factory replacement were instead repaired, fabricated, or replaced using alternative solutions. The involvement of Mat Armstrong and his team helped turn a damaged supercar into a running, driving machine again. The process was not smooth and included many failures, including radiator damage, welding leaks, and alignment issues. However, each problem was solved step by step. The final result proved that limits in automotive repair are not always fixed. They can sometimes be pushed further with the right approach. While manufacturers like Bugatti designed their cars for controlled environments, this project showed that real-world repair can sometimes achieve similar results using different methods. The success of the first drive marked the completion of a long and difficult journey. It also left a strong message for viewers. Complex machines are not always beyond repair, even when they seem completely destroyed. During the rebuild of the Bugatti Chiron, one of the least visible but most important factors was the constant mental pressure on the team. Working on a hypercar of this level is not just about mechanical skill. It is also about decision-making under stress. Every step carried risk. If a mistake was made on a normal car, it could be fixed quickly. But in this case, even a small error could damage extremely expensive parts or delay the project for weeks. Because of this, the team had to stay focused at all times. When problems happened, they could not panic or rush. Instead, they had to slow down, analyze the issue, and find practical solutions. This mindset became a key part of the project. For example, when the radiator issues kept repeating, the solution was not to force the same approach again, but step back and rebuild the entire system carefully. This kind of thinking is what separates simple repair work from advanced engineering problem solving. Another important factor was communication between team members. Fabrication, mechanical work, and installation all had to work together perfectly. If one area moved ahead too fast, it could create more problems in another area. So the workflow had to stay balanced. Even though the project looked chaotic from the outside, internally it required structure and discipline. This hidden layer of planning and thinking is often not seen in video content, but it plays a huge role in making the final result successful. One of the most surprising lessons from rebuilding the Bugatti Chiron was how small changes in measurements created large system-level problems. In normal cars, a difference of 1 millimeter might not matter much. But in a hypercar designed with extreme precision, even the smallest change can affect multiple systems at once. For example, a slightly thicker radiator core changed the alignment of mounting points. This then affected how brackets fitted, which then affected how pipes connected, which then caused leaks. This chain reaction shows how tightly connected modern car systems are. Nothing works in isolation. Every part depends on another part fitting perfectly. This is why factory-built cars use highly controlled manufacturing processes, where every part is measured and tested multiple times. In the rebuild project, the team had to recreate that same level of accuracy without factory tools. This is extremely difficult because they were working with limited information and damaged original parts. However, through careful measurement and repeated testing, they were able to gradually correct these issues. This part of the project highlights an important truth in engineering. Complexity is not only about big components like engines or chassis frames. Sometimes, the smallest components create the biggest challenges. Understanding this relationship between small details and large systems was one of the key reasons the project eventually succeeded. A major reason the project on the Bugatti Chiron succeeded was the experience of the fabricator working on it. Skilled hands often mattered just as much as advanced tools. In this case, the fabricator known as Bob played a central role in rebuilding parts that could not be purchased or replaced. His experience allowed him to look at damaged components and understand how they were originally designed, even without full technical drawings. This ability comes from years of working with metal, machines, and performance vehicles. For example, when rebuilding the front crash structure, there was no exact guide or blueprint available. Instead, the work had to be done by studying the shape, stress points, and connection areas of the original broken part. Then, using tools like welding machines, cutting tools, and bending equipment, he rebuilt it piece by piece. This kind of fabrication is not just technical, it is also creative. It requires imagining how the part should look and function before it even exists. Many people underestimate how much experience matters in projects like this. While modern technology like 3D scanning and CAD design is very powerful, it cannot always replace hands-on skill, especially when data is missing. In this project, experience filled the gaps that technology cannot cover. The final stage of the rebuild of the Bugatti Chiron was not just about starting the engine or driving slowly. It was about full system testing under real conditions. Once the car was confirmed to be mechanically stable, it had to prove itself on the road. This meant checking everything at once: cooling, power delivery, braking response, steering alignment, and structural stability. Each system had to work together without failure. The first drive showed that the car was not only functional, but also stable under acceleration. This was a major confirmation that the rebuild was successful. It proved that the engine cooling system could handle heat, that the transmission could deliver power smoothly, and that the chassis repairs were strong enough to handle stress. This stage of testing is important because a car can look fine in a workshop, but fail under real driving conditions. The success of this test showed that the rebuild was not just cosmetic or partial. It was complete. It also demonstrated that with enough time and skill, even highly advanced machines can be restored outside of their original manufacturing environment. This does not mean factory methods are not important, but it shows that alternative approaches can also achieve strong results when applied carefully. In the end, the project became a combination of engineering, creativity, and persistence, all working together to bring a heavily damaged hypercar back to life. The rebuild of the Bugatti Chiron also highlights why hypercars are so difficult to repair in the first place. Unlike normal cars, these machines are built with extremely tight engineering limits. Every part is designed to work together in a very controlled environment, where temperature, pressure, and material behavior are all carefully calculated. This means that when something breaks, it is not always easy to replace it with similar part from another source. Even small differences in material strength or shape can affect how the whole system behaves. For example, a slightly different radiator thickness or bracket position can change airflow, cooling efficiency, and mounting stress. This is why manufacturers like Bugatti usually prefer full part replacements instead of repairs. In their factories, everything is designed to be precise and repeatable, using advanced machines and testing systems. However, outside of that environment, things become much more complicated. In the rebuild project, the team had to deal with missing parts, damaged structures, and limited technical data. This forced them to rely on observation, experience, and trial and error. It shows that repairing a hypercar is not just about fixing broken pieces, but about understanding the entire system as one connected structure.